Hi all. So this is our new topic. We are going to be learning all about data representation. And for those of you that don't know, that's going to consist of a lot of binary. Now, the big question for these 4 to 5 weeks is going to be, how do you turn electricity into words? Now, that's a strange concept, isn't it? How is it that we're able to type an A on our keyboard and the computer knows that we need to have an A on the screen? How do we have these words on this screen at this precise moment? It's all about how electricity is perceived by the computer and then translated into something else. Today, we are going to concentrate on the absolute basics. How do we convert binary numbers to decimal numbers? Now, imagine trying to use words to describe every scene in a film, or every note in a song, or every street in Leicester. I mean, it's practically impossible. I mean, imagine trying to describe every street in Leicester and how they all interconnect. It would be insane. But now, try and imagine doing it just using the numbers 1 and 0. That is what computers do all the time. Every time you use the internet to watch a movie, listen to music, check directions, play games, talk to people on social media, it is just ones and zeros. Your device is translating binary code into something that you're doing. Computers use binary code because the CPUs contain transistors that can be on or off. Binary number doesn't have to have a predetermined meaning, though, on its own. It could mean different things for different types of software that we use. It just depends on the context. For example, if we are using Microsoft Excel, this binary number could mean the number 71. If we're using Microsoft Word, that same binary number could be a capital G. If we're using Photoshop, maybe that binary number could be the color red. But is binary the future of computing? Well, maybe and maybe not. There is research into ternary computers with circuits that are in three possible states and not just two. There's also quantum computers whose circuits can be multiple states simultaneously. However, both of these things aren't very reliable when it comes to actual data storage and transmission. So, for the foreseeable future, we are going to be looking at binary. Just true or false, ones and zeros, ons and offs. Everything that we do on our digital computer screens is because of those transistors, those little switches that can either be on or off. And as computer scientists, we really need to know the basics of binary. So, how can we convert binary numbers to decimal numbers so we can understand them? Well, to answer that, we need to start by understanding how we as humans actually count numbers. Now, to answer that question, I'm going to ask another one again. Why in our decimal number system do we use 10 digits? I'm going to ask your teacher just to pause there for a second so we can get some answers. Well, in decimal numbers, we use 10 digits because we started counting as humans, I'm almost certain, while we were still cavemen and women. It was all about counting with our fingers. I'm almost certain that if we had 14 fingers, then our number system would go up in 14s, but it doesn't. It goes up in 10s. So, what number is this? Well, that's the number 49, isn't it? Our mind automatically knows that that number is 49. Of course it does. I mean, we've been counting since the day we were born, so all of this kind of stuff becomes automatic for us. It becomes second nature. But how is this number actually 49? How do we know? Well, we write 49 in this way. This is called the decimal number system because if you have a look there at the units, tens, hundreds, and thousands, and you can carry on into the tens of thousands and hundreds of thousands, each one of those columns go up in factors of 10. We multiply each column by 10 each time, hence decimal. And in each column, we can only have numbers from 0 to 9. We couldn't put 10 in one of those columns because that 1 would have to spill over onto the next column. So we can only have numbers from 0 to 9. This is actually how we know it's 49 because we have 9 units plus 4 tens. And we know that adding those two calculations up, we're going to get the number 49. So now we know how humans count. How do computers count numbers? Well, we know that the CPUs are made up of billions of switches called transistors, right? They can either be on or off. Computers don't have 10 fingers, they only have little switches. And those switches can either be on or 1 or off, which is 0. So what's the proper name for this? Some of you may correctly be saying, well, that's a bicycle. Well, why is it a bicycle? Well, it's a bicycle because it's got 2 wheels. If it had 1 wheel, it would be a unicycle. If it had 3 wheels, it'd be a tricycle. But we know that it's a bicycle. Any word really with the prefix bi is all about the number 2. And earlier we learned that any word that has the prefix dec, or for example decimal, is all about the number 10. So if we go back to our decimal number system, we multiplied each of our column headings by 10. In the binary number system, we will multiply each column by what? By 2. Which means that when we're filling out those columns, we are going to start from our units, multiply that by 2, which gives us 2. Then the next one is 4, and then we double it again to 8, then to 16, to 32, to 64, and 128, and so on. That is how the binary number system works. And in the decimal number system, each one of those columns could have numbers from 0 to 9. But in the binary number system, each column can only contain numbers from 0 to 1. Exactly. So that there at the bottom is an example of a binary number. That means nothing to us as humans. 0110 is definitely computer talk. Now, what we need to do is take that binary number 0110 and convert it to a decimal number. We start at the units like we did for the number 49. We've got 0 lots of units, so we might as well ignore that. We know that 0 times 1 is always going to be 0, and 0 times 8 later on is going to be 0, so we're going to ignore those columns. But when a column has a 1 underneath it, like the 2's column, we do need to count that. We also count the 4's, but again, we don't count the 8's because it has a 0 underneath it, so we'll just ignore it. There's something else that we can abstract from this equation, and that's 1 times. We know that 1 times 2 is always going to be 2, and 1 times 4 is always going to be 4, and because 1's the only number that there's ever going to be, we can get rid of those as well, can't we? So we know that binary number there, 0110, is the same as 2 plus 4, which we all know is 6. Now, can we all, in our books, flip to a fresh page, write today's date, and the title, Data Representation. And please copy down as neatly as you can the example that's on your screen and the explanation that's there. You will, when converting binary numbers to decimal numbers, you will add up the columns that contain a 1 and ignore the columns that contain a 0.